Now, from the data that you can get from the preceding video, you should actually be able to determine the mass of the car as a multiple of the mass of a domino. Now, these dominoes don't have absolutely uniform mass, so there's a certain there's a significant degree of uncertainty that results from that inconsistency of domino masses. However, again, another uncertainty that we just want to take into account. Now, I'm going to use the ramp and a domino and a stack of dominoes to determine the approximate mass of the cart as a multiple of the mass of a domino. So here we go. First, I'm going to simply balance the ramp, or the groove track, or whatever you want to call it. Okay, I see that the track teeters a little bit more toward that end than toward this end, so I'm going to move it back just a fraction of a millimeter. Okay, that's teetering pretty uniformly on the two ends. Now what I'm going to do is I'm going to put a domino underneath this end, and I'm going to place the cart at the end of the track. Then I'm going to place a stack of, let's say, 4 dominoes. Okay, stack of 4 dominoes on this end, and see what happens. See if that's clearly too much. Okay, if I take my finger away, or if I lower this end, the dominoes are going to move the system. So I'll take a domino off, and now I'll see what happens if I lower. Well, that's still, these dominoes are still enough to counterbalance the car. So I'll take another domino off, and oh, look at that. Okay, the 2 dominoes is not sufficient to balance the car. 2 dominoes are not sufficient to balance the car. So I'll add back the 3rd domino, and I'm going to move the dominoes a little closer. Okay, to the fulcrum, to the center point here. Now, I moved them quite a ways, and the car stayed where it was. Moved them back a little more. Move them back a little more. Move them back a little more, and there we have liftoff. These dominoes are balancing the weight of the car. And we'll take that for now to be a sufficient indication of the relative mass of 3 dominoes against the car. The 3 dominoes at the end here are more than enough to balance the car, but moved this far from the end, they do balance the mass of the car. From what you can see here, you can estimate this distance, okay, distance from the car to the fulcrum, as a multiple of this distance, or this distance as a multiple or as a fraction of that distance, and get a pretty good indication of the mass of the car as a multiple of the mass of a domino. And you can do that using simple common sense. You don't have to do a formal analysis. There's simple proportionalities involved, and I would expect everybody to be able to make a reasonable estimate. So we see again the mass of the car is somewhere between the mass of 2 dominoes and 3 dominoes, and from what you see here, you should be able to estimate that. And I'm actually going to do one more estimate. I'm going to put 2 dominoes down here, and I'm going to move the car. Okay, so if I move the car to here, move the car to here. Okay, there we got the counterbalance. Okay, so we've got to move the car back a little bit. Oh, look at that. Balance is there. Now there's a range of positions at which the car would balance. There's a finite thickness of the domino here. And those all contribute to the uncertainty in this estimate, but you can now make an estimate of the mass of the car as a multiple of the mass of 2 dominoes based on these relative distances, and see if that estimate is consistent with the estimate you could have made with the 3 dominoes sitting here and the car at the end.